Good day everyone. I am Sofia Bianca L. Alombro from BSCE 3B, and this is my oral recitation in Dynamics of Rigid Bodies with my chosen topic, rectilinear motion. So what is rectilinear motion? Rectilinear motion is a motion that describes the movement of a particle or a body. The motion of a body is said to be a rectilinear if it moves in a straight line. In other words, rectilinear motion are motion that moves along a straight line. So some examples of rectilinear motion includes a marching band, a bullet train moving along its track, a car or train moving along a straight line, and the movement of elevators. Rectilinear motion is divided into two main types, the uniform motion and the uniform acceleration. In uniform motion, velocity is constant. When velocity is constant, your acceleration is zero. In uniform acceleration, if your acceleration is constant, your velocity changes at a constant rate. Therefore, when the problem states that the velocity is constant, you can use the formula s is equals to velocity times time. If the problem states that the acceleration is constant, you can use the formulas s is equals to v initial times t plus 1/2 at squared. V final is equals to v initial plus at. V final squared is equals to v initial squared plus 2as. And we also have our variable acceleration, where v is equals to the derivative of s over dt. Acceleration is equal to the derivative of v over dt, and ads is equals to v dv. We can use this variable acceleration to derive our formulas from uniform acceleration.
So now I'm gonna show you the derivation of the formulas. So these are the formulas from the uniform acceleration, and I'm gonna show you how we come up with these formulas using the formulas of variable acceleration. And v final squared is equals to v initial squared plus 2as. Okay, so these are the one that we're going to derive. And remember, these are our formulas from variable acceleration. A is equals to dv over dt, and ads equals to v dv. And we will derive this equation first. So the derivation of the rectilinear motion came from the definition of acceleration. So acceleration is defined as the rate of change of velocity with time. So in equation, our acceleration is equals to the rate of change of velocity over time. So our delta v is also equals to vf minus v initial. So simplifying, so cross multiply, we have 80 equals to v final minus v initial. So as you can see, we can transfer our initial velocity to the other side to equate our v final. So v final equals to our v initial plus our acceleration times time, and this is our first equation or the first formula that we derived. So now we'll derive this formula using this variable acceleration formula. So v is equals to ds over dt. Cross multiply, we have v dt equals to ds, and we'll integrate this one. So integration of ds with limits 0 to s, and this one from 0 to t with respect to t. So integral of ds, we have s, and we'll substitute this later, 0 to s with its limit, and t0. So as you can see, our v here is our v initial plus at times dt. So this is s, substitute 0, because s substitute to s, we have s, 0 substitute to s, we have 0. So solving, we have v initial dt plus a t dt. So this is cancel 0, s equals to v initial derivative of dt, integral of dt, we have t. So from 0 to t, plus a derivative of t dt. So we have t squared over 2. So from 0 to t. So we'll substitute this limit. So VOT minus VO times 0 plus our a t squared over 2 minus 8 times 0 squared over 2. So this is cancel. So we are now left with v initial times time plus 1/2 at squared. And this is our second equation, or the second formula that we derived. Equation number 2. Okay, so lastly, we're going to derive this formula. So using our variable acceleration formula, we have ADS equals to VdV. So ADS equals to VdV. Again, we'll integrate this. So from V, our limits will be from V initial to final velocity, and this one from 0 to s. So integral of v, we have v squared over 2. Our limits from v initial to v equals to acceleration, and then ds 0 to s to a. Okay, so we'll substitute our limits to our answer. We have v squared over 2 minus v initial squared over 2. Integral of ds, we have s, and then limits from 0 to s. So v squared over 2 minus v initial squared over 2. Substituting, we have as minus a times 0. So this is cancel. So we are now left with v squared over 2 minus v initial squared over 2 and as. And we'll multiply this by 2 both sides so that we can cancel the denominator. So we have v squared minus v initial squared equals to 2as. And again, we can transfer our v initial to the other side. So we have v squared equals to v initial squared plus 2as. And this is the final formula that we derived. Equation number 3. So we derived our formulas using our variable acceleration formulas.
For problem number 1, we have a truck traveling along a straight road at speed of 20 kilometers per hour. Increase its speed to 120 kilometers per hour in 15 seconds. Letter A. What is the constant acceleration in meter per second squared? Letter B. Determine the total distance traveled.
Okay, so from our problem, we have our given here. V initial is equals to 20 km per hour. Our V final is equals to 120 km per hour. And our given time is equals to 15 seconds. So it is asked in the problem, what is the constant acceleration in meter per second squared? So that means we have to convert our velocity to meter per second. So converting it to meter per second, we have our 20 kilometer per hour, which we all know that 1,000 meter is equivalent to 1 kilometer. So multiplied by 1 hour, which is equivalent to 3,600 seconds. So cancel. And we have, so 20 times 1,000 over 3,600. So 5.56. So 5.56 meter per second. Next is our V final, which is 120 kilometer per hour times again 1,000 meter over 1 kilometer times 1 hour over 3,600 seconds. So again, cancel. And we have 33.33 meter per second, and that is our V final. So we now converted our given to meter per second. So let's now proceed at solving letter A. So letter A is looking for the acceleration in meter per second squared. So since we have our V final and our V initial already converted as well as our time, so we can use the formula Vf is equals to V initial plus 80. So we have our Vf 33.33 meter per second. So we just plugged it in. And our V initial, which is 5.56 plus our acceleration, which is unknown, and our given time, which is 15 seconds. So solving it, we have so we have 1.85 meter per second squared. And this is our answer to letter A, our acceleration. So for letter B, so we have to identify the total distance traveled, which is again in meters. So we already have our acceleration here. So for solving for S, we can use this formula VOT plus 1/2 AT squared. So our initial, we have 5.56. And our time 15 plus 1/2 our acceleration, which we solved 1.85, and then time 15 squared. So S goes to, so just calculate it. So plus 1/2 times 1.85 times 15, we have 291.525. So 291.53 meters. And this is our distance for letter B.
For problem number 2, an automobile starting from rest speeds up to 40 meter per second with a constant acceleration of 4 meter per second squared, runs at this speed for a time, and finally comes to rest with deceleration of 5 meter per second squared. If the total distance traveled is 1,000 meters, letter A, find the distance covered during the acceleration. Letter B, find the distance traveled at constant speed. And finally, letter C, find the total time of travel.
Okay, so for problem number 3, we have to draw a diagram to further analyze and understand our problem. So in our problem, it states that the automobile starts from rest. So that means our velocity, our initial velocity is equals to 0. So from 0, it speeds up to 40 meter per second. So that will be our 1. And then it says that it runs at this speed for a time. So that means from this velocity, it remains constant. So that means it is still 40 meter per second. And after that, our final velocity is not given or not stated. So in here, it has a constant acceleration of 4 meter per second squared. Our velocity is constant, so our acceleration is 0. And from here, our acceleration on this velocity, it decelerates to -5 meter per second squared. And our final velocity is unknown or not stated. So the total distance traveled of the automobile is equals to 1,000 meters. So the distance here is S1, distance here is S2, and S3. So since we have our S1, S2, and S3, we can put T1 here, and then T2, and the time taking here. So we can now proceed to solving letter A. Okay, so from this, we'll focus on this part and we'll treat our V1 as our final velocity. The final velocity is 40 meter per second, and our initial at 0. And our acceleration is 4 meter per second squared. So now we'll be solving for our S, which is our unknown. And we can use the formula Vs squared equals to Va circle TAS. We have our Vf squared, which is 4p squared, and the 0 plus 2, our acceleration of 4, and our unknown, which is S1. While calculating, our S1 is equal to so our S1 is equals to 200 meters. Now we have our S1 here. This can also solve for our time 1, which is using with formula Vx equals to V naught plus in T. Our final velocity of 40, our initial 0, acceleration of 4, and our time. So we can see here that 40 divided by 4, we have 10 steps. Okay, so for letter V, it says that the distance, it asks for the distance traveled at constant speed. So we'll be looking at this part. So from this part to this part. So we'll focus on here. It says that our speed is constant, meaning our velocity is constant. So when velocity is constant, our acceleration is equal to 0. Therefore, we'll be using this formula. So the formula that we're going to use is S times velocity times time. Well, since our S is still unknown, and our time is also not given or unknown, so we'll rearrange this equation or formula to V is equals to S2 over T2. And we have our given velocity of 40 meter per second and S2n over T2, and we'll leave it as it is as of now. So moving to this final part of the diagram, so we can solve for our S3 and our T3. So using again this formula, so our final velocity is not stated, therefore it is 0. And our initial velocity will be 40 meter per second. So we can solve for the T3 and we can solve for the S3. So our acceleration, it decelerates to -5 meter per second squared. So solving for S3, we can use this formula.
LC.
So our final velocity, which is 0 squared, equals to 40 squared plus 2, our deceleration of -5, and our unknown, which is S3. So solving for S3, we have 40 squared So we have 160 as our x as 3, 160 meters. So it says that our total distance traveled is 1,000 meter. And we already solved for our S1 and our S3. So our unknown now is S2, but we can equate this to 1,000 meters. To solve for the S2, so our S1 we have 200. Our S2 which is unknown. Our S3 we have 160 meters equal to 1,000 meters. So solving for S2 we have 1,000 minus 200 minus 160. Our S2 is equals to So our S2 is equals to 200. 160. So our S is equals to 640 meters. And that is our answer to letter B. So from this, we can finally solve for our time 2. So our S2, 640 meters over time 2. So simplifying, we have, so T2 is equals to, so T2 is equals to 16 seconds. Okay, so now we have our T2, we have our T1. By the way, this is the answer to letter B, which is a distance traveled at constant speed. So now moving on to letter C, we have to find the total time of travel. So we have our T1 plus T2 plus T3 equals to the total time. Okay, so our T1, we have 10 seconds, 16 seconds, and we forgot to solve for the time 3. 16 seconds. Plus our T3, so going back here, we'll solve for the T3. So again, using this formula. So 0 final velocity, 40 initial, acceleration of -5, and T3. So our T3 is So our T2 is 8 seconds. So 8 seconds.
I'm sorry.
So 10 plus 16 plus 8. Our total time is 34 seconds.
That team and I became award to stop operation. Even in
And this is our final answer to letter C. So our S1 again 200 meters. And our S2 we have 640. And finally our letter C, our total time we have.
Problem number 3. A car is traveling at a speed of v initial in a straight level road. After the brakes are applied at 0 time, the motion can be approximated by x is equals to t cubed over 100 minus t squared plus 17t, where x is the distance traveled in meters and t is the time in seconds. Letter A. Which of the following gives the value of v0 or v initial? Letter B. Which of the following gives the distance required for the car to stop? And letter C. Which of the following gives the maximum acceleration during braking?
Okay, so for our problem number 3, letter A, so it asks for what is the value of our V initial. And based on the problem, we have a given equation of x equals to t cubed over 100 minus t squared plus 17t. So going back to our formulas in variable acceleration, we can solve this by v is equals to ds over dt. So our s is our distance here, which is x, is also the same as s. So we'll form this as ds over dt equals to, so we'll just derive this equation. We have 1 over 100 derivative of t cubed, 3t squared, minus derivative of t squared, we have 2t and 17. So we'll put a condition wherein, so simplify, we have 3t squared over 100 minus 2t plus 17. Next is, in the problem, it states that what is the value of v initial when t is equals to 0. So technically, this is our velocity. So velocity, substitute the value of 0 to t, and we have, we'll cancel this one. Our velocity, we're left with 17 meter per seconds. And this is our initial velocity. Answer to letter A. Okay, so for letter B, it asks for the distance required for the car to stop. We'll use this equation of velocity. So velocity is equals to 3t squared over 100 minus 2t plus 17. We'll equate our velocity. So this is x is our distance. So this is velocity. Again, so copy 3t squared over 100 minus 2t plus 17. And we'll equate our v is equals to 0. So we have, so when v is equals to 0, what is our time? So 0 is equals to 30 squared, substitute, 3t squared over 100 minus 2t plus 17. So simplifying, okay, so this is over 1 over 100 divided by 101 times 3t squared, so 3t squared. 100 divided by 1 times 2t, we have 100 times 2t. And then 100 divided by 1 times 17, we have 100 times 17. So 100 cross multiply, we have 0. So simplifying, we have this equation. So as you can see, this is a quadratic equation. So we can simply plug it in our calculator. So we have 3, then negative 200, and 1,700. So our first value we have, so for T1 we have 56.67, and T2 we have 10 seconds. So we'll pick the second value, which is the 10. We'll pick this one. And going back to our original equation of distance, which is this one. So x equals to t cubed over 100 again minus t squared plus 17t. And then substitute our value, which is t is equals to 10. We'll substitute this to this equation. So t substituting plus 17 times 10. Our x is equals to 10 squared plus 17 times 10. So we have 80 meters. x equals to 80 meters. And this is our answer to letter B. And finally, for letter C, it asks for the maximum acceleration. So we have again released the equation of the letter T equals B is equals K, 3 P's and over value. And again, going back, this is an operator methodology. B is equals to B is in P. So remember, we have variable acceleration formula of A is equals to dv over dt. So this is dv over dt, and we'll derive this equation. We have 6c over like 100 minus 2. Or this is below. Again, so what is acceleration? So this is acceleration. So what is our acceleration with when t is equals to 0? So simply substitute where 100 minus 2. So cancel. Our acceleration is negative 2 meter per second squared. So our acceleration, so it decelerates, and this is our, we have 17 meter per second squared. Our value of x, we have 80 meters. And our value to acceleration is